Today, I want to talk about solving limits in the indeterminate form infinity minus infinity. And yes, that is an indeterminate form. Now, why is that? It's because some infinities are larger than others. For example, the infinite number of integers is larger than the infinite amount of natural numbers, right? So we have infinity minus infinity, one will be larger than the other, and we won't be able to determine which, so it's indeterminate rather than zero. So here we have our first limit, right? And if we try to plug in 0, we get 1 over 0 here, and we get 1 over 0 there. So that's infinity minus infinity, right? And we can start off by combining this into one fraction. So we'll get the limit as x approaches 0 of, this will become x minus e to the x minus 1 over x e to the x minus 1, okay? Then, from there, what we're going to do is, let's try to plug in 0 and see what we get. Well, we plug in it here and we'll get 0, and then here as well, and this will be 1 minus 1, so that's 0, and then down here we'll also have 0. So we have 0 over 0 now. Now we can apply L'Hopital's. But before we do that, let's multiply this out. So this will equal the limit as x approaches 0 of, this will become x minus e to the x plus 1 over x e to the x minus x, right? Then from there, we can apply L'Hopital's and it'll be a lot easier for us. And we have the limit as x approaches 0 of, this will become 1 minus derivative of e to the x is e to the x, right? The 1 plus 1 goes away. Then down here we have derivative of x, which is 1 times e to the x, that's e to the x. Then we have x times derivative of e to the x, right, plus that. So that'll just be x times e to the x. And then we have minus 1, because derivative of negative x is negative 1. Then from there, what can we do? Well, let's test it out. Up here, if we try to apply in 0, we get 1 minus 1, that's 0. Right now, looking good. Then we go down here, and we get 1. That'll be minus 1, and then this is 0. So we have 0 over 0 still. Let's apply L'Hopital's again. So then, this will equal the limit as x approaches 0 of, this will just become negative e to the x over, this will become e to the x plus e to the x plus x e to the x, and that minus 1 will go away, right? Then from there, let's test it out. We put 0 up here, we get negative 1. That's great. We no longer have an indeterminate form, right? So we should be able to evaluate. Then we go down here, and that's plus 1, that's plus 1, that's plus 0, right? So this, we have negative 1 over 2, which is negative 1/2, right? And that's our limit. Then let's go up to this one. Now this one, we can see if we go here. Let me make this a little bit more obvious for you. This will also equal the limit as x approaches infinity of x to the 5 minus x squared, right? Then plus x minus 8, right? So obviously right here we have infinity minus infinity, right? And we think we would have an issue, and we do have an issue. But this is a very, very, very simple thing to fix, right? Rather than trying to put it into a different form or apply L'Hopital's or do anything to it, right? All we're going to do is we're going to say this equals the limit as x approaches infinity. So that's as x approaches infinity of, we can just factor out x cubed here. We get x cubed, x squared minus 1, right? And then this is b plus x minus 8, right? Now, what I want you to observe is this is infinity, and this is infinity. So here we have infinity times infinity, then plus infinity. Infinity times infinity is just infinity, plus infinity is still infinity. So this equals infinity. And that is our final answer for this limit. Thank you for watching. Let me know if there's anything wrong or if you have anything additional to add. Have a great day.